Okay, so in this lecture, I'm going to build on what I talked about in the last lecture and explain how you can build a multi-threaded online tic-tac-toe. This is a much more realistic online game that could handle multiple games and multiple users. So you're only limited in this case by the server's capacity. You could probably run thousands of games simultaneously if you wanted to using this approach. So multiple people can play tic-tac-toe online. It's still got limited functionality. Yes, it handles multiple users, got lots of threads in it, blah, 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 but it's not fully tested. It's just a demo. It's probably got lots of bugs. I didn't bother fixing the shutdown, so it's not very clean. But it's, again, the idea of this is not to be production code that I make my £1 million from. The idea is it's a simple bit of code that you can use and adapt for your projects. So it extends the simple online tic-tac-toe. So it's using a similar board class, but instead of sending the board around, it's sending messages around, and these messages are used to update the boards on the player and update the board on the server. And a couple of lectures ago, I showed you how you could build a multi-threaded TCP server, and this multi-threaded tic-tac-toe is building on that same idea. So in the simple tic-tac-toe, we start up player 1, which is the server, and then player 2 connects to that server and plays the game. In this case, we have our server class or main class, and that's launching a connection listener. And then we have our clients, tic-tac-toe clients. So the first client connects to the connection listener, and then it waits for a second connection from a second client, and then passes them off. Once it's got 2 clients, it passes them off to a game handler, and the game handler runs as a separate thread and manages the game between the 2 clients. And while this game is going on, the connection listener is still sitting there waiting for connections, and then when another 2 clients connect, it passes them off to another game handler. So the connection listener is always there, always waiting for new 2 clients to connect, and each game is handled by a specific class that runs as a separate thread. So I'll give you a little demo of this, make it all clear. So here we have, right, so I've already started this. So this is the, I'll just stop it, show you what I'm doing. So here, this is the, so here we have this is the code for this example. And I'm going to start up the server in NetBeans to make things a bit easier. So there we have the NetBeans, started up in NetBeans, and I've got 2 clients that I've started up on the command line. So this is the usual. I've changed to the build directory and typing Java, the multiplayer tic-tac-toe, which is the package, .tic-tac-toe client. So I've started the clients, and the clients present this menu: play tic-tac-toe if they enter 1, or exit if they enter 2. So they're not currently connected to the server. They'll only connect to the server when I choose to play tic-tac-toe. So let's start the first client up. Let's connect the first client up. So let's press 1. And the client's connected to the server, but there's no game yet because he needs a friend to play with, right? It's still a little bit lonely there. So we'll start up the second client. It's already started, but we'll connect the second client, and now we're both connected. So now, for whatever reason, I can't remember how this is selected, but this first client's allocated to crosses. So this client goes first. So it's the usual thing. So this client enters 0, space 0. Then the messages are used to messages sent to the second client, and the second client displays the current state of the board. You can see that it needs to make its move. So it enters 1, 0. It's going to be another lame game, I'm afraid. Then the first client, first user types 0, 1. Second client, still hasn't learned from previous mistakes, so types in 2. Not quite what it's trying to do, I've no idea. And the first client then types in 0, 2, and that turns out that that's a winning move, very gripping. So we get the message that the first client's won, they get the message first client's lost, and then we revert to this play tic-tac-toe or exit. So now the connection's dropped, the clients are still working, and they can choose to connect again, start another game if they want to. Okay, so that's what it looks like in practice. Not too dissimilar. The only difference is that you could run as many clients as you like simultaneously and lots of different games simultaneously using the threading capabilities. So the architecture is more complex as you'd expect. So we've got the same interface that defining all the things that don't change throughout the program. We've got the board class that doesn't change. And then we've got these connection listener, game handler, message, tic-tac-toe client, and tic-tac-toe server. So this is the more complex bit with multiple threads and multiple games and so on. So the constants interface is kind of similar. The first bit's pretty similar. I'll talk about the meaning of this in a little bit. So in fact now. So in the constants interface, I've got this final Boolean debug equals true. Because we're running multiple threads, debuggers of limited use because things are happening sort of simultaneously. If we step through one, heaven knows what will happen. So instead, I've got this debug variable. And whenever I want to track what's going on, I can switch this debug I can switch it on to set the debugging output to be true, or I can set it to be false, in which case I won't get any debugging output. So here, whenever I put a system out call, I put debug first, if debug, system.out.println, whatever. And I can also put these debug variables into the classes themselves, so I can switch on debugging for just the game handler, or switch it on for the connection listener and so on. Or I can have a global debug, or a combination of them, so I can have like a global debug and switch that on, and then switch off debugging for particular classes and so on and so forth. So by using this kind of approach, you can do a nice control the output that you're getting from the program and switch it off completely for the production one, for the production version, if there was one. Now, within the constants interface, we also have message types. So, as I said, this version of tic-tac-toe uses messages instead of sending the board around. So you've got different types of messages. There's ready message, there's a player draw message, a player one message, and so on. I'm not going to go through all the details here. And again, the mark types are the same as previously. As I said, yeah, so the classes that want to use the constants just have to implement the interface. And we've got the board class, which is broadly similar to the simple tic-tac-toe game. It's got your methods for adding noughts and crosses, checking when the game's finished, getting the winner playing, getting the winning player, and printing out the board in the rather crude way that I've done. Now, in the simple tic-tac-toe, the player one had the board and passed it to player two passed it back to player one, so on and so forth. In this version of the game, we've got 3 copies of the board, which is a bit like, I mean, I'm no expert on this, but a bit like, I imagine, like a racing game or something like that, some kind of proper online game. Most likely you're going to have a copy of the game engine on the server that's used to calculate the player-player collisions and send updates to the clients. And the clients are also going to have a copy of the game engine that they use for the rendering and to display their local actions and interactions. So here we have copies of the board here, here, and here. And they're used in different ways. So this game handler copy of the board is used to determine whether the game's been won, and then it updates. And these client copies of the board are used to check that do some error handling on when the client enters a mark. It checks that the board position's empty or not, and is used to display the updated. So this one, say, puts a nought here. That sends a message to the game handler. That game handler checks to see whether that nought has led to the winning of the game or not. If it hasn't, it sends the update message to here so that this client here knows that this client has entered a nought on the board. As I said, you could get rid of these client copies if you wanted by adding a couple more messages. You could eliminate the server copy if the clients decided whether they'd won, and the server just sort of would route messages instead of actually hold a copy of the messages. Lots of different ways of building these things. I picked one of them. Which is the best is who knows. Okay, so this, as I said, this works with messages instead of by sending the board around. So we've got a message class here, and it's a class that's passed using the object stream. It implements serializable, and what it's got a message type. So this is just this is what is defined in the constants interface. Lots of different message types, and depending on the message type, we're going to interpret the other contents of the message in different ways. So, for example, we've got an add nought message. Then, if we've got an add nought message, then we're going to use xpos and ypos because we need to know where the nought was added. Whereas, if it's like a game one message or something, we wouldn't bother reading these fields from the message class. It has to be serializable, so we can send it across the sockets. And then we got the sort of the main method of the thing, which I'm calling the server. It's more the connection listener, is a bit more like the server really. The main method just starts up the connection listener and waits for the user to type stop, and then when the user types stop, it shuts down the server, and in theory shuts everything else down, but I had a few problems with that, which because of the blocking input from the user, but that could be fixed. So yeah, that's the server, and the server starts the connection listener, and that's a separate thread, and it waits for connections from players. When it's got two connections, it launches a game handler, and it's the game handler that actually plays the game. So that's the connection listener launched by the server, and the connection listener accepts connection from one's client, adds that to the handler, receives a connection from a second socket, adds that to the handler, and then it runs the what's it doing? Yeah, then it starts up the starts up a separate thread that runs the game handler as a separate thread. The game handler runs one game between two players, chooses which player is naught, which player is cross, which is naught, coordinates term taking, and has a local copy of the board and notifies the players when the game is complete. And there's one instance of this game handler per game. That's the game handler there, so that's handling a game between one set of clients. So it's got input and output streams from both of the clients, which it's using to read and write the messages to and from the clients. It's got a copy of the board. So it waits until it receives a message from the two clients. Then it allocates the marks to the players. And then it, what's it doing there? Yeah, so it's waiting for a cross message, adds that to the board, checks to see if the game's over, and then it's sending the updated board, a message with the updated state of the board to the naught, waits for the naught to make a change to the board, checks to see if the game's over, and then goes back to the beginning. So it's receiving a message from the cross, updating the board, checking to see if the game's over, sending the new state of the board to the naught, and repeating that process until the game finishes. And the client's just a simple front end for the user that allows them to connect to the server and then actually play the game with another player. So there's the clients at the bottom there. And yeah, it's same idea, object inputs and output streams. And so the gameplay on the client side, it's just depending on the message it receives, it either updates the board, reads a move from the player, or displays that the user has won or lost. And this is read player move, so this is what's the reading the 0, 0 or the 0, 1 or whatever from the user, and using that to update the board, and then sending a message to the client telling the server that the user 1, let's say, has put a cross at this particular position on the board. So you can run it in NetBeans, and you can also run the command line exactly the same way, typing Java, naming the package, and then the name of the class. I've already gone through this in the previous talks, I think. So all the example codes are available on the course website. So you can run it, have a look through it, play with it, have a play with it. You can look at it. We'll maybe go through it in the lab sessions, and you're welcome to ask questions about it in the lab sessions. I would recommend, if you're struggling with this project, that you start with a simple version, because the first year I ran this, I think no one used this code or found it helpful. The groups that did really badly are the ones that started by trying to modify this code. So it's quite tricky. There's quite a few threads in it. I wouldn't take this as your starting point. I'd only take this as your starting point if you're quite confident in Java and you're making good progress on the game, and you're like, hey, let's make this so we can run it across play lots of different games, see lots of different people. So it's there for you to use, but I only recommend you use it if you're feeling quite confident about threads and sockets. So again, the messages in this case, so your project report should have the classes, all the different classes I've explained, giving some nice architecture diagrams about how they work together to deliver the game. You could list the messages in a table, be quite sensible, and you could use some of the diagrams to explain how the architecture works. Again, don't include screenshots of code, please. So there's an online version of Tic Tac Toe graphics, which I mentioned in the previous talk. I'll just wrap it up. So This is a quick demo. It's not a beautifully polished bit of code. You probably could run it like now, and people could, in this very crude way, play tic-tac-toe across the world using this system. But it's got lots of limitations. It's a bit rubbish, really. There might even be better ways of building a turn-taking tic-tac-toe game. So you don't have to use it, but it might be a useful starting point for your projects. As usual, 0 marks for an online version of tic-tac-toe, so don't hand this in and claim you've done your project. I'm expecting to see signs that you've taken this code and adapted it for your own game. I haven't done your project for you. So this took me, I don't know, can't remember how long it took me, maybe a day fiddling around with it. Can't quite remember now, it was a while. But it's quite fiddly, because you've got threads with blocking reads and lots of different things going on at the same time, in parallel. It's quite tricky to get multi-threaded stuff like this working. Expect some nights, dark nights, of bleak despair, right? You don't know why it's broken, and you keep fiddling with it, trying to make it work, and it just won't work, and you're making it worse. So, this stuff can be hard to debug and take some time and effort. But once it's working, you can add lots of fun stuff. You can add some graphics. You can add more sophisticated, games, some more sophisticated rules, better functionality. So, it can take some work to get all this going, but, it'll be worth it in the end. Okay, so this lecture has explained how you can build a more sophisticated online tic-tac-toe game, uses threads, multiple clients and games simultaneously. So it's quite powerful in what it can do, even though it could be done a lot better. And next lecture, I'm going to talk about a racing game. So just to give you a little illustration of how you can do the real-time sort of interactions using UDP, and how a combination of TCP and UDP could work.